Hello and welcome to this amazing playlist on Python tricks. And in this video, we are going to see the difference between the equality operator and the is operator in Python. And essentially, when we talk about object comparison in Python, there are two main operators that I just talked about, which is the double equals and the is operator in Python. And we are going to see the difference between these two operators in this video. So when we talk about object comparison, we are essentially trying to do two things. One is we are trying to compare the values of the objects. For example, there is an object. You can think of an object as a container, and that particular container contains some value. Now, there is another object, which is also a container, and it contains some value. So we are trying to essentially match the values. We are trying to see whether or not these two values are same or not. Second thing that we try to do is to see whether or not the objects that we are comparing, the containers that we are comparing, are they the same object or the same container or not? What do I mean by that? So basically, whenever you define an object in Python, Python is supposed to create a new object for you. And every object that is created by Python has a unique identifier associated with it. So that particular unique identifier remains constant throughout. It remains constant till that object lives or till that object is alive. And every object have their respective unique identifier, which means if there are two objects and you say that both the objects have same identifier, which means we are essentially talking about the same object. If the identifiers are different, then they are different objects. So don't worry if you didn't understand. We are going to see some really cool examples from now on, and we'll try to understand the difference between the is and the double equals operator. By the way, double equals operator is also called as the equality operator, and is also called as identity operator. So which means when we talk about values, we are essentially talking about the equality operator. It checks the values inside the containers. And when we talk about matching the identity, comparing the identity of the two objects, then we are talking about the is operator. So let's see a very basic example and you will understand about it more. So let's create two lists. So I have a list which contains 1, 2, 3, and I create another list which also contains 1, 2, 3, right? So I have two lists here. Now, Python should essentially create an object for this, for variable A, and Python should create an object for variable B. We are newly defining these objects. So these objects are also lists and they contain the same item, they contain the same values. So what we expect when we compare them based on the equality operator. So let me print that. So if I do A equals B, so what do we expect the output should be? So let's run this and see. So you see that it prints true, which is fine. That's what we knew, right? So equality operator checks whether or not two objects have the same value. But now let's print A is B, and we'll see what the output will be. So it prints false. Why did it print false? So understand that whenever we define an object in Python, Python creates a new object for us. Whenever we define an object, Python creates a new object for us. And of course, in this case, even though both A and B contain the same values, Python is going to create two different objects. One is A, another one is B, and they both are going to contain same values, which is 1, 2, 3 and 1, 2, 3. So when you compare both of these objects, because their values are same, so this equality operator, which is the double equals, is going to return true. And then if you compare it based on the identity operator, it is going to return false. So that's what we saw here. We saw false for the identity operator and true for the equality operator. So let's try to modify our example slightly. So let's say here in this case, I don't want to create a new object for B, rather I want to have B assigned with A, which means B equals A. So, and now in this case, we are going to see what is going to be the output for both of these print statements. So let's run our code and see what happens. So you see that earlier it was true and followed by false, but now it is true and true. Why is so? Let's try to understand that. So what essentially happens is when we defined A, Python created a new object for us, right? Python created a new object for us, and A will be pointing to that particular object. Now, when we assigned A to B, Python did not create a new object. Rather, now B will start pointing to the object that was created in the previous step, which A is also pointing to, which means now B and A are the variables that are pointing to the same object. Because they are pointing to the same object, which means essentially they are going to contain same values. Hence, we see true here. Also, because they are same objects, B is going to return true because they are the same object. They will have the same identifier. If you want to check the value of the identifier of a particular object, you can check that using the utility function provided by Python called ID. So let's see that how that works. So let's say here we are expecting, here we have already seen, not expecting, we have already seen that A is B has returned true, which means the identifier, the value of that particular identifier is going to be the same for both A and B because they are pointing to the same object. So let's print that. So let's say I print a identifier, the value of that particular identifier for A, and let's print the value of that particular identifier for B. And let's run this and see what's the output. So here we see that the identifier is printed here, and you see that they both are the same values. They are same integer values. So that also indicates that A and B are pointing to the same object. Because we have seen this example, let's see that what was when we had B defined like this. In this case, what would have been printed for identifiers? So let's run that. So in this case, you would see that the value of these identifiers are different, which means that they both are pointing to the different objects. And that's why we have already seen that A is B. In this case, when B and A both are separately defined, in this case, A is B will always return false. But now we know the reason, because the identifier values, that unique identifier for both of these objects are different, which means they both are different objects. Now that you have a basic understanding of the difference between the equality operator and the identity operator, which is double equals and the is operator, we are going to see some really cool examples which may give really surprising results. So for now, let's I'll probably switch to the console of the interactive Python. So let me do that. So let me clear it out here. Let me clear everything. Now here, let me open the Python's interactive shell. So let me create a variable which is A, but it has a value 100. So in Python, everything is an object. So integer is also an object. So we have created an object, integer object. Now we create another variable, which is B, right? So let's print the value of A equals B, which is true, right? This is what we expected. Now let's print the value of A is B. But this is also true. How? In this case, we did not assign A to B. Rather, we created B from scratch. We defined B explicitly. So how is that the value of A is B same? In the previous example, we have seen that when we defined A as separate list and B as separate list, even though they contained the same values, the value of A is B was false. But why is it true here? Think of it. If you didn't know the answer, then no problem. Let me tell you. Python has a concept which is called as integer caching. So as part of this concept, before you do anything, Python will pre-create the integer objects for all the integers lying between the range -5 and 256. It also includes -5 and 256. So Python has already pre-created the integer objects for all the integers in that range. So I am trying to define a variable which will be an integer object with value 100. And since 100 lies in that range, Python is going to point this variable A to that pre-created object. Similarly, when I try to create a variable B with value 100, again, then B is also going to point to that same pre-created object. And that's why we see that A is B is true. They both are pointing to the same object. For more clarity, let us create A and B with some other value which is outside that range and see what happens. So let's say that I create A with value 300 and I create B with value 300 again. Now, if I print A equals B, we know that this will always result in true. But if we print A is B in this case, now you see that it is printing false. Here we created 100 and A is B resulted in true. Now we created A is 3 as 300, B as 300. Now A is B has resulted in false. And this can get pretty confusing if you don't know the underlying concept behind this. So let me show you another cool example, but this time with respect to string. So let me open the Python's interactive console again. Let me define a string A, a variable A that contains a string. Let's say it contains X and X is repeated 20 times. So A is a string which is X, which contains X repeated 20 times. Similarly, I'll create a string B, which also contains X, and X is also repeated 20 times in case of B as well, which means A and B are the exactly same string. And the string contains character X, which is repeated 20 times. Now, let's try to see what's the output of A equals B and A is B. At this point, what we expect from Python, we expect that Python will create a separate object for both A and B, right? And because we are explicitly defining them, right? So let's print and we'll discuss more about it. So let's print A equals B. So that will be true. There is no confusion about A equals B. However, A is B, that also comes as true, which means Python hasn't created separate object for B. It's the same object as A. And why is so? So this is because of the concept called string interning in Python. As per a string interning concept, each time you create a new string, and that new string is exactly same as the previously created new string, then Python is not going to create a new string object for you. If that's confusing, no worries at all. We are going to look at this example and understand about it. So let's see here. So at this step, we defined a variable A that contained this string. What is that string? This is the string. So character X repeated 20 times. So we created this string. So at this point, we didn't have that string created previously. So Python is going to create a string object for us. Now, in the very next step, we are creating the same string again, right? We are creating the same string. Now, this time, we are going to assign that particular string to the variable B. But at this point, Python is not going to create a new object for us. Reason is the same string object has already been created in the previous step, or it has already been created previously. So Python is not going to create a new string object at this step, which means after this, if you refer A or B, you are actually referring to the same string object. So let's quickly verify that as well. So let's say if I take ID and pass A to it, so it gives me the identifier. And now if I take ID and pass B to it, so you will see that they are pointing to the exact same object, right? This identifier or this memory address is pointing to the same string object. So one small caveat here is that if the string length is less than 4096 or less than or equal to 4096, then this string interning will kick in, otherwise it won't. For example, let me show that as well. So let's say I create A again, but this time, or let me create another variable which is P, and it contains X repeated, let's say 4097 times, right? And I create another variable which is Q. Now at this time, Q contains X, and that is also repeated, let's say 4097 times, right? Now, if we do P equals Q, there shouldn't be any confusion about that, right? But if we do P is Q and it shows me false, now you see that, which means Python at this point has created two different objects. Earlier we saw the same thing, but the only difference was that we created a string of length 20. This time we created a string of length 4097. If the length of the string that you're creating is less than or equal to 4096, then the concept of string interning will kick in. Otherwise, if it is 4097 or greater than 4097, then Python is going to create new string object every time you create a new string. So if you didn't understand, or if you have any confusions still, then let me summarize the difference between double equals and the is operator for you in Python so that it's crystal clear. So in the case of double equals, I think whatever the cases that we have seen so far, it's pretty straightforward. So if we have object A and if we have object B, the content inside object A and object B will be compared, and if they are equal, then A equals B is going to return me true, or else it is going to return me false if the content are not same, right? If the content is not same. Otherwise, if the content is same, no matter what, it is going to return me true. Confusion or the problem arise when we use the is operator, right? That's what we are going to see. So let me clear this space again. So in case of is operator, now let's see the mutable type. So for all the mutable type, list, dict, set, if you create, for example, A equals to list or a dict, A equals to some dict and B equals to some dict, right? Then Python is going to create a separate object at this point. Then Python is going to create a separate object at this point, right? Now in this case, B is going to return false, right? Similarly, if you create a list, A equals list or B equals list, like that, that's where we started. So A equals to some list and B equals to some list. So Python is going to create a new object here and a new object here, or a new container. So A is B is again going to return false. So which means in case of mutable types, whether it's list, dict, or set, Python is, every time you define a mutable type, Python is going to create a new object, right? And B is always going to return false because they both are the different objects. They both are different objects, right? However, let's say you created a list. Let's say like this, A equals 1, 2, 3, and you created B equals A. Now in this case, this is a different case. Here we are not defining a list from scratch like this. Rather, we are doing B equals A, which means now A and B are pointing to the same object here. They both are pointing to the same object. In this case, A is B is going to return me true because they are pointing to the same object. That's why. So this is the case of mutable type. So the problem occurs when we use the immutable types, especially integer and string, with the is operator, right? So let's say if we create A equals, specifically talking about the integer caching. So A equals to 100 and B equals to 100. This 100 falls in this range, right? So Python is going to apply a memory optimization technique, which is also called as integer caching or integer interning, according to which if you define A equals to 100, and at that point, Python will already have a pre-created object for 100. So basically Python creates for every integer inclusive of -5 and 256, every integer lying between this range, Python will have a pre-created object for it, integer object for it. So if you define A equals to 100 like this, then A is going to point to that pre-created object of 100. Similarly, if you do B equals to 100, in that case also B is going to point to that 100 only, right? Because Python already has pre-created these objects. It's not going to create another object. That is purely for memory optimization, right? So in this case, what will happen if you do A is B? This is always going to return you true. Unlike in the mutable type, when we saw that we created a list here, we especially defined it like this, and then we again defined B like this. But in this case, A is B was returning us false. Why was so? Because for mutable types, Python is always going to create new object. Here, we again defined this is an integer object that we are creating, unlike this list object. This is immutable type. Integer is immutable type. So in this case, if you create the list integer like this, then Python is not going to create new object. Rather, Python will have its own pre-created object and Python will point A and B to that. So that's why B is going to return as false. However, if you create any object, integer object that is outside of this range, for example, if I create -100, or and b equals to -100, then of course in this case Python is going to create a new object here and new object here, and then b will be false. It's pretty simple to understand. We also saw the case of a string interning. So essentially it can be divided into three parts. So let's say in part one, you create a string a equals to some string, let's say str1, and b equals to str2. So str1, str2, I'm writing it like that because so that you would understand that these two strings are not the same strings. They have different content, like the strings are not equal. Right? So in this case, anyway, Python is going to create separate objects for a string. And in this case, A is B is going to return you false. Why? Because they both are different objects, right? Let's come to the case 2. The problem arises when you create A equals to str1 and B equals to str1, which means now these strings are same. They have the same value. So what will happen? Now here, Case 1 is where the length of the string is less than equals to 4096. In this case, what happens? In this case, A is B is going to return you true. Why? Because Python does the string interning. As per this concept, if you repetitively create strings, repetitively define new strings, and that particular newly defined string is same as the previous string, also the length of, because they are same, and also length of these strings are less than equal to 496, then Python is only going to create one string object in the end, and A and B both are going to point to that string object. So only one string object will be created. A and B will be pointing to that object only, and that's why A is B will always be true in this case. However, in the third case, this was case 1, let's say case 2. In this case, if the length is greater than 4096, then in this case, for A equals to str1, B equals to str1, then Python is going to create new object here, Python is going to create new object here, and that's why A is B is going to return you false. I hope it was pretty clear to understand that where the string interning will play the role or where it won't come into the picture. So I have included tuples as the third special case under immutable types. So immutable types, here we just spoke about integer and string. Now in this case, in case of tuples especially, so you can think that there may be something on memory optimization for something called as tuple interning, but there is nothing like that. So in case of tuple is a special immutable case where when you define a tuple, right? Tuple is again, it's a sequence, right? So if you define a tuple like this, the items inside tuple can be mutable, right? So you can have a list inside a tuple, and that particular list is a mutable type, which means if you create a tuple here like this, and if you create B tuple again like this, even though they contain same item, you may define exact same item in this, so they may contain exact same values, Python is going to create a new object for this tuple. Python is again going to create a new object for this tuple, and hence in that case A is B is always going to return you false. And that's what I wanted to convey. So tuple is unlike the immutable types integer and string. There is no memory optimization as such in this case. So if you create a tuple, if you every time define a tuple, then A is B is going to return false for those two tuples that you have created. However, of course, if you create a tuple like this and then you do B equals A, now in this case, B is of course going to return you true because A and B both will be pointing to the same tuple. That's not what I'm talking about. I'm talking about if you create every time new tuple, then even though tuple is an immutable type, there won't be any tuple memory optimization technique applied on tuple. And with that, I hope that you liked the video and you understood what I wanted to convey with the summary and all the examples that we have seen previously in this video. And if you liked it, please like, share, and subscribe to my YouTube channel. And if you really like the video, probably you can follow me on LinkedIn for more such content. And thank you for watching. I'll see you in the next one.